Hi, in this video we're going to be talking about phasor diagrams and how to calculate power on an RC circuit that's powered by an AC source. In the previous video we calculated the voltage in the capacitor when we were powering our circuit with this power source, and this is what we calculated. Now we might be also interested in calculating the voltage in the resistor. As we mentioned before, when we're dealing with such circuits, we can still use the laws that we know already, like Ohm's law and Kirchhoff's law. So in order to calculate the voltage in the resistor, we can apply Kirchhoff's mesh rule, which says that the sum of the voltages in a mesh is equal to 0. That means, in this case, if we have that our input voltage is this, then the mesh equation would be minus input voltage plus voltage in the resistor plus voltage in the capacitor equals to 0. Since we know the input voltage and the voltage in the capacitor, we can calculate the voltage in the resistor, which would be voltage in the resistor is equal to input voltage minus the voltage in the capacitor. Now, in order to be able to subtract complex numbers, we need to have them in Cartesian form. So we can calculate this. In this case, this is my magnitude and the phase. So the real part of my number would be the magnitude times the cosine of my phase. So that would be 3.5 times cosine of minus 45 degrees. That gives me 2.5. And the same here for the imaginary part. I have 3.5 times sine of minus 45 degrees times j. So that gives me minus 2.5j. Now, in the case of my voltage source, our phasor representation of my voltage source, we saw that it was 5 volts at 0 degrees because there is no phase here. And this is the magnitude, so I have it automatically in phasor form like that, in phasor form. So the input voltage in Cartesian form would be the magnitude times sine of 0, which is 1. So, times cosine of 0, which is 1. So I would have 5 volts in the real part. And the imaginary part is 5 volts times sine of 0 times j. And sine of 0 is 0, so I have 0j. So, now I put these two. That one comes here, and this one here. And we can calculate then the voltage in the resistor, which is 5 plus 0j minus, that's volts, minus 2.5 minus 2.5j volts. So I add the real parts together. Sorry, there's something wrong here. So I add the real parts together and the imaginary parts together. So I'm going to take out the parentheses first. So 5 plus 0j minus 2.5 plus 2.5j, and all of this is volts. So my voltage in the resistor, I add the real part here, which is 2.5, and the imaginary part here, 0j plus 2.5j gives me plus 2.5j volts. And again, this in phasor representation would be the magnitude of this would be 2.5 squared plus 2.5 squared and square root of that, which gives me 3.5. And the angle here would be the inverse tangent of 2.5, this 2.5 over this 2.5, which gives plus 45 degrees. So now we have all the voltages in our circuit. So basically we have the voltage in the source, the voltage in the capacitor, and the voltage in the resistor. So we can basically plot these in a Phasor diagram, which basically will just plot these voltages in the complex plane. So our complex plane would look more or less like this. So I have here the real part and here the imaginary part. So our voltage source has got a magnitude of 5 volts, so 5 in real and 0 imaginary. So I just draw a vector. I'm going to put them in different colors so that we can see. Let's put our input voltage in red. So my input voltage is a vector here, which is 5 at 0 degrees. And then we have the voltage in the capacitor. We said that it's this voltage here, 2.5 minus 2.5 J. So I'm going to put that in blue. So I have 2.5 here minus 2.5 here. So I plot a vector here. So I have here the voltage in the capacitor, which was says 3.5 at minus 45 degrees. So note here, that is minus 45 degrees angle here. And the length of this vector is its magnitude, which is 3.5 volts. And the voltage in the resistor would be 2.5 plus 2.5 J. So I'm going to plot that in green. In green, no, this one, this one, this one. In green. So I have the 2.5 from here and 2.5 here. So I come here, and this is my voltage in the resistor, which is 3.5 at plus 45 degrees. And then this is also 45 degrees. And one nice thing is that when we have the vectors like this, we know that the sum of these two vectors of VR plus VC is equal to VI, thanks to Kirchhoff. We can also add the vectors as we know. Basically, I just pull my lines like this, and I draw this line like this. Or if I know, say, the voltage in the source and the voltage in the capacitor and want to calculate my voltage in the resistor, what I do is I join the two ends of the vectors together, right? And we said that the voltage in the resistor is the voltage, the input voltage minus the capacitor voltage. So so my vector goes from the capacitor to the input voltage. So it goes from the capacitor to the input voltage, so the arrow goes here. And once I have this drawn, it's got the right magnitude and the right angle, I can just translate it to the origin here so that I get this vector like this. So that is how I plot my Phasor diagram. In the next video, we're going to talk about how we calculate the power of this circuit. Thanks for watching.